These series of videos are demonstrating how to automate economic policy through code. A link to the GitHub repository is included in the video description. The previous video toured the project code at a high level. In this one, we're building a new environment following the instructions on the README so viewers know how to get themselves set up at the helm and understand all its knobs and dials. Let's get to it. Step 1. Clone the repo. Did that in the previous video. Moving on. Step 2. Install project dependencies listed under the root install makefile target. Open the root makefile and scroll to the install target. You need Go for all of the backend services except the rules service. Go version, check. The rules service is in TypeScript because it loads modules dynamically at runtime. It's either all or nothing in a statically typed language, so the rules service was written in TypeScript to avoid managing an unruly number of imports. You need Node for rules and local development of the web client. Node version, check. NPM version, check. You need the AWS CLI to fetch secrets, deploy lambdas, and other commands. AWS version, check. Terraform, which uses your AWS CLI creds, is required for the infrastructure. Terraform version, check. libpq is just a Postgres client. pSQL version, check. You need Golang migrate for database migrations. Migrate version, check. JQ is required for working with JSON and shell commands. JQ version, check. ESLint if you're using this editor with JavaScript. ESLint version, check. Finally, there's Docker, which is currently used for local Postgres development. You can get it from their website. Docker version, check. Now, these videos are not tutorials in any of these tools. Plenty of those online. Go bootcamp yourself, then come back. Okay, we're done with step 2. Step 3. Set S3 bucket names in root project JSON to unused values. In the project root, there's a project JSON file. Open it. The values in this object set the names of 2 buckets. 1. The name of the bucket where you'll store artifacts. 2. The name of the bucket where you'll serve a client. Change these values to something new because the current names are taken. Also, these names are prefixes for every new environment you build for this project. So when you build a dev environment, a dev suffix will be automatically added. When you build a stage environment, a stage suffix will be automatically added. Don't add suffixes here. In case you missed it, they're added automatically in a later step. Okay, you've named your artifact and origin buckets to something different. Save the change to the file. Step 3 is complete. Step 4. Add logging permissions to US East 1 API Gateway. The calling module for this API Gateway logging permission is located under Infrastructure, Terraform, AWS, Environments, and US East 1. All the stacks are currently under the Environments directory. Copy the command from the README, then from project root in a terminal, paste the command and hit enter. Now type yes and hit enter again. Wait for the operation to finish. With an apply complete message, API Gateway logging permission is added. Step 4 complete. Step 5. Create artifact and origin buckets by duplicating and customizing resources in this directory as some new directory. In other words, we're copying some items in this folder here to a new folder and customizing. Let's create that new folder in the Environments directory, naming it init stage, following the convention of init dev and init prod. Copy main tf from init dev, paste it in the init stage directory. Now repeat for storage TF. Copy from init dev, paste in init stage. Your init stage directory will now have 2 copied files in it: main TF, storage TF. Now let's customize these duplicated files. In init stage main TF, nothing requires changing. To avoid confusing cadets, we'll store the Terraform state file locally, but you can get fancier if you want. In init stage storage TF, just replace all occurrences of dev with stage. Only 2 occurrences, change them to stage. Done. Now we need to cd into this new directory and apply. cd infrastructure, Terraform, AWS, environments, and init stage. Now Terraform init and Terraform apply. Type yes and enter. Step 5 complete. Step 6. From project root, build and push all artifacts to S3 with this command. Open a shell to project root, copy the command, paste. We'll show the makefile command we're running, but hit enter. We're now compiling, zipping, and pushing all the project artifacts to the new S3 artifact bucket we created moments ago. This step is required because the backend is currently just a handful of cheap lambdas that will mature into constantly running containers managed by a container orchestrator. For now, to bootstrap development for an approximate expense of $25 a month per environment, we get by with some lambdas and a small database. Okay, all artifacts are built and pushed. Step 6 is done. Step 7. Create infrastructure by duplicating and customizing resources in this directory as a new directory. Under Environments, add a stage directory, maintaining convention with the dev and prod directories. Now, from the dev directory, copy the main TF file and paste it in the new stage directory. Next, open the duplicated stage main TF and customize by replacing all occurrences of dev with stage. Only 2 occurrences of dev here, replace them with stage. We're done customizing. From a terminal, cd into this new stage directory. cd infrastructure, Terraform, AWS, environments, stage. Terraform init and Terraform apply. Type yes and select enter. Now, those of you who know cloud and heard the phrase database and servers may be jumping right now saying, hey, there are no servers because you're using serverless. Serverless is a misnomer. A computer is serving requests, it's just not running all the time and you don't have to manage it. Keep in mind this video may be viewed by someone who doesn't have to babysit constantly running servers for a living. Don't want to confuse them. Okay, our new stage environment is up. Step 7 is complete. 3 more to go. Step 8. Deploy migrations to a new environment RDS with these commands. Open a new shell to project root. Copy this command. Paste. Fire. You are currently deploying schema, seed, and test data to your new RDS Postgres instance. While we're waiting, switching out RDS for timescale and EC2 is planned, but this command will be kept around and you won't see a difference in behavior. Alright, DB migrations deployed, step 8 complete. Step 9. Deploy client with these commands. In terminal, cd up back into project root. Copy from README, paste. Now fire those commands. Client deployed. Step 9 complete. Step 10. From project root, make get secrets to store newly created environment values in a root.env file for manual testing in a browser. Using the same shell, cd up, copy command, paste, fire. In the project root, You'll notice a new .n file appear. Open it. One address points to your new client. Copy it. Paste it in the address bar of a browser. There it is. Now test creating a user. That fetch balance lambda needed a moment to warm up, but the initial 1000 balance appeared for this new user. Okay, let's test the backend address. Copy address, back to browser, paste in address bar, and fire. There's your backend. Step 10 complete, anchors away. In the next video, we'll set up our Postgres database locally and tour the schema so viewers understand the data model. We'll skip the physics. That content is just the voice of information science shouting orders in a barracks full of idle physicists to march on economics before it's too late. If they want to occupy themselves with their chicken scratch instead, mathematical concepts may be expressed as data structures is enough to move without them. We won't be stopping to first earn a language certificate from William Clifford or Rob Pike. You may subscribe, share, and contribute from the buttons and links in the description.